Okay, today's lesson is going to be on finding the measure of the interior angles of a hexagon. And the prior knowledge that a student should know before this lesson is that a triangle has 180 degrees. And so first, as you ask your students to divide up a hexagon into triangles, they have many different options that they can use. The first option is to do it randomly. So let's say a student divides up a hexagon like this. The only rule is that all the pieces must be triangles. And so in this case, there are 1, 2, 3, 4, 5 triangles. And so a student would then take 180 and multiply it by 5. And find that there are 900 degrees. However, there's a problem. And the problem is that there are some angles that are not actually interior angles. This is an interior angle, this is interior, this is interior, this is interior, this and this are all interior. However, these three angles in here are not. The good thing about this is that we know that a straight line is 180 degrees, so we simply subtract 180 and find that the measure of the interior angles of a hexagon is 720 degrees. Now let's say they're a little bit more systematic about how they find their triangles. Let's say they start at one point and they fan out to all of the other vertices. In this case, they have 1, 2, 3, 4 triangles, and they have no excess angles in the middle or anywhere else on the interior of their hexagon. And so all they need to do here is multiply 4 by 180 to get the same total of 720 degrees. Thirdly, they might find that using a central point and making it kind of like the spokes of a wheel out to the other vertices makes more sense to them. So in this case, they're going to have 6 triangles. And 6 times 180 is 1080. Again, we have our problem of extra angles, and in this case, we have an entire point and all of the degrees around it are in excess, so we subtract 360 to again get 720 degrees. Now, are any of these better or worse than the others? In my opinion, this one, there's nothing wrong with it in exploration. However, there's no systematic way to use this model for other polygons. However, the other two can be used more systematically. For instance, this one, when you do what I call the fan-out method, you'll always have 2 less triangles than the number of sides. So in this case, we have 6 sides on our polygon and 4 triangles. The formula then would be n minus 2, n being the number of sides, multiplied by 180, 180 being the degrees in a triangle. And you can use this for any polygon. This formula over here, which I like to talk about as the spokes of a wheel, you always have the same number of triangles as the number of sides. In this case, we have 6. So you take 180 times n again being the number of sides, and you get all of the triangles. But you always have 360 degrees in excess in the middle for your central angles. So you always have to subtract 360. Sometimes students confuse these two and they think, how can I have 2 different formulas for the same, finding the same measures of the interior angles of a polygon? Well, really, they're not different at all, because if you distribute the 180 here, you'll have 180n minus 360. This way, students can use whatever way makes most sense to them to find the interior angles of a polygon.